Hi, this is Keith Bryant for Global SMT and Packaging at Apex 2022, and I'm here with Scott from Macdermid Alpha, and we're going to talk about their new low-temperature solder paste. So, Joe, tell me about it.
So, thank you for having us, and appreciate the opportunity to sit and talk to you about something that we're really excited about. We're coming out with a new alloy in the low temperature space. Low temperature space is slowly coming along and it's getting to be more and more looked at. But what's interesting about the low temperature space is that as more and more customers, and let me start with the high end on that aspect, and then we'll get into the alloy itself. As more and more customers are concerned about sustainability and global footprint and how these NGOs and others are rating people, we have a way to help with that. When you're looking at a low temperature alloy solution, again, it was making sure that it meets all of the requirements that you have for your specific application. When you're looking at low temperature, what it can do for you in the macro, say for an SMT, for example, you use less energy. We're now talking about peak reflow temperatures not only under 200 degrees C, but 175. So we need less energy to run those ovens, which means if we're running the ovens at cooler temperatures, we need less HVAC to run the temperature. So it has a less negative impact on the environment. So that's kind of partial of the interest. The other aspect of it is that one of the big problems with low temperature has always been brittleness. It's the whole thing with the bismuth alloy, the tin bismuth alloy, and how it's gotten a bad rap over the years because, well, it's frankly, some of it's deserved. But with the latest technologies in low temperature, what we're able to do is take some of the good things of low temp, which is bringing the temperature of the reflow down, but we're also able to, through dopants and through grain modifiers, able to change the structure of it so that we get similar drop shock performance and, more importantly, thermal cycle performance to SAC 305. Yet at lower temperatures. So what does that do for us? Well, if you talk to the chip manufacturers such as Intel, where they have the big chipsets, they have a tendency to have a high signature warp to them. And these chips, especially when they go to SAC 305 reflow temperatures, they have a tendency to really warp 250, 280, 300 microns. And that causes a defect called non-wet opens. However, these chipsets tend to go flat around 175. So if you're peaking at 175 and the chipsets go flat at 175, defects like head and pillow, non-wet open, go away. Additionally, what we're doing now is because we're not putting as much heat into the board, we're able to now, and it's hard to really tangibly measure, but we're able to put more reliability into the product because we're not taking it to such a high thermal excursion. So depending upon what your application is, low temperature solder is something that is very exciting and very interesting coming forward. And again, with the new alloys that are coming out, because we've been in low temp for a while. We had our alloy HRL1, which was a 190 peak type material. And we've now got this new one that's going to be launching next month, commercially available, called HRL3, which has these better dopants and grain refiners in it, so it can bring that temperature down a little bit. But it doesn't stop there. We also have another material that's called OM220, and this material is designed to be able to reflow at under 150 degrees C.
Wow.
It coalesces at under 150 degrees C. And what's neat about that is that when you're talking about flex circuits, the big thing with that has always been, well, I can't use PET, which is 1/10 the cost of polyimide, because I can't solder to it because the temperatures are too high. I'll turn it into a potato chip.
Yep.
However, PET, most PETs, can handle about 150 for about 10 minutes. Well, with this new technology that we've come out with, which is a tin bismuth indium-based type material with other dopants and grain refiners in it, it's able to now fully coalesce under 150 C, so that now for medical devices, for low-cost applications where you want to pull price out of things, like if you're building, I don't know, an Alexa or something like that, and you have flex circuits in it, you can now use much lower cost substrates because we now have another enabling low temperature technology. Going back to HRL3, one of the other things that's been interesting is that this particular alloy now allows us to be able to use it in selective soldering. So you now have an SMT solution and a selective soldering solution with the same alloy, which really hasn't been done before because everybody's been working on the tin bismuth eutectic or tin bismuth silver, and it's okay, but it doesn't give the drop shock and it doesn't give the thermal cycle performance that we've wanted. Now, with these new technologies, we're able to provide a much broader base of solutions depending upon the application.
Yeah, so it's giving you a much broader field. The one thing that you didn't mention was electrolytic growth. So,
okay, so when it comes to electrochemical migration is a function of the chemistry, not so much the alloy. So now what we've had to do is we've had to reformulate in the SMT side new chemistries that still give us the passing results that we need, because that's a non-starter. If you have electrochemical migration issues, you don't have a product. So we now have new chemistries that are available with these products for the SMT line, for the SMT world, and also in the lower temperature, where we can fully coalesce all of those activator packages and stuff that we use in those fluxes are designed to be able to work at those targeted reflow temperatures. And in the wave solder flux for the selective wave, we have tested a number of our commercially available materials and have found that we can pass electromigration requirements, 004B, 004A, with some of these fluxes at these little bit lower temperatures. Because remember, in selective, we're still at a little bit higher temperature, but just not quite as high as SAC 305.
Yeah, so you're pretty much ticking all the boxes as we go through.
We're trying. We're certainly trying. One of the really neat things about being part of the Macdermid Alpha family is the fact that we have solutions across semiconductor, surface finish, and assembly in the electronics world, so we can talk to the right people and have expertise in the right areas, where instead of just finger pointing. So when we want to have questions about surface finishes and how these materials work with surface finishes, we can go right to the experts because they're in-house. And when it comes to these new alloys, we collaborate across other divisions to see what's your needs, where are we missing here, what are we missing there. So it just brings a little bit of a edge to when we're putting these things out.
Yeah, I suppose it's not quite customer feedback, but it's definitely market feedback.
Well, what it does is it allows us to be able to go and say, okay, when you're developing a new solder paste, how does it interact with the surface protectants? Well, we understand the surface protectants, and we understand the chemistries. So we're able to talk to the right people. For example, we just had paper here at the show this week where we talked about what types of fluxes work better and how do you make a flux work better with OSP surface finish, because OSP is now 60% of the market. So working with the teams between the surface finish solutions and then the assembly solutions, we're able to see that, you know what, these solvents and these fluxes actually work better on cutting OSP than some of these do. But also these activators go after the copper 2 and copper 4 because that's what you're creating. It's a good paper, it's worth a read. But we're able to collaborate better. Plus, so you add that into the camp, plus customer feedback, and puts us in a good, strong position.
Yeah, it gives you a lot of advantages over a lot of the other low temperature people that are out there at the moment, I guess. Well,
we were very fortunate to have some really good commercial partners that were driving us, so to speak, like the chip manufacturers, because what we were able to do by coming out with HRL1 and now HRL3 is we were able to accelerate their ability to go to market with some of these very large chipsets, because the warping situation was just so bad with SAC 305 and the temperatures required to reflow that they needed to come up with some better solution. And this enabled them to do that.
Yep. So my last question, what about cleaning?
Cleaning is always a really interesting topic, and there's so many variables when it comes to cleaning. It's a function of the material that you're using, the ability of the process that you're using too. Before I get to that, and then the type of cleaner that you have. We at Macdermid Alpha have a couple of different cleaners, but I got to be honest with you, the people that are really good at that are the Zestrons and the Kaizens and the Microcares and those types of people that do this and focus on that. So from a chemistry step perspective, they're the guys that can help us, and we work with them and give them our materials to test. So we have a library of test results where they've taken our materials and cleaned them in their cleaners and come up and say, this one's better, this one's not so good, this one's that, this one's this. When it comes to cleaning specifically low temperature materials, we're still in the process of getting that. I can't remember off the top of my head which ones are or which ones aren't a good cleaner from some of these other third-party vendors. But cleanability is something that is absolutely getting to be more and more important, especially now that we've gotten into the underfill and edge bond business with our Alpha high-tech materials. So low standoff materials, or excuse me, low standoff components, they have a tendency to, sometimes you need to get underneath there. So some chemistries that we have are better cleaning than others, but there's so many variables on that. If somebody had a specific need or concern about that, get a hold of us and we will work with the third party, or we'll work with trying to find a better solution for you.
Okay, Scott, well, I think we've just about covered all the bases now, so thank you very much for coming in and sharing with us, and I hope the new product goes well after its official launch.
Perfect. Thank you so much for this opportunity. We greatly appreciate it, and we're very excited about it, and we're here to help.
And that's Keith Bryant signing off from Global SMT and Packaging at Apex 2022.